right, we're going to start chapter 2, which is going to be on lines. We're going to move through this chapter fairly quickly because it's going to be a review of stuff you've done several times before. We're going to graph slope-intercept form. We're going to graph standard form. We will just discuss graphing from intercepts and from points and slopes. And we'll talk about the expectations I have of when you give me a graph. Let's start with this question. What is a graph? Okay. Like, pause and think about this for a second. What is a graph? And to be really clear, this right here is not a graph. That's called graph paper, potentially. In this case, it's a coordinate plane, sometimes called a Cartesian plane. It's the space upon which we graph, but not actually a graph. So graph paper isn't called graph paper because it's a bunch of paper with graphs. It's called graph paper because it's the paper upon which we graph. Suppose I had some equation, 2x plus 3y equals 6. That's different than the equation 2x plus 3 equals 6. In the equation 2x plus 3 equals 6, x can only be one thing, 1.5. If x is 1.5, then 2x plus 3 equals 6. But if you have two variables, x and y, suddenly there's a lot of possibilities of what x can be and what y can be. For example, if x is 3, y is 0. Or if x is 0, y is 2. Or if x is 6, y is negative 2. There's actually an infinite number of things that x and y can be in tandem that satisfy this equation and make it work. So we graph those. We have the point 3, 0, we have the point 0, 2, we have the point 6, negative 2. One of these doesn't quite seem right. Why is that? 12 minus 6 does equal 6. 6, 6. Yeah. These are all good. Nope, I'm fine. They look off, but they're fine. A line kind of like this is showing every single possible solution to the equation 2x plus 3y equals 6. Because there's two variables in one equation, there's a whole host of possibilities. The line shows them all and extends forever. So a graph in an algebra setting is a visual representation of solutions to an equation or a system or whatever it is that you're solving. It's basically a picture of all the points that work. Okay? So our graphs need to be clear demonstrations of the possible solutions to an equation. Let's start with slope-intercept form. You've graphed this once or twice before, I'm pretty sure. Slope-intercept form gives you two things, a slope and a y-intercept. Here's our slope. We call it mm. The slope is negative 4 over 3. We know that slope is rise over run. Always think of the negative as being attached to the rise. Okay? So this is going to go down 4, but right 3. Think of the negative like it's attached to the rise. Have the run always go to the right. This is the y-intercept. The y-intercept is 2. That means that my graph starts at 2 on the y-axis. That's my y-intercept. And from there it goes down 4, right 3. Down 4, right 3. Once you can't go down and right anymore, go up and left. Now, my last graph I drew, I didn't use a straight edge. Use a straight edge every single time. And if you're graphing on something like Notability or some app that allows you to do straight lines, take advantage of it. Also, always use a clear coordinate grid, have labeled scales and axes, and label a few points. So I know that this is the point 0, 2. And I'm going to grab one other point. Here's the point 3, negative 2. I'm going to check this point. This is called a checkpoint. I'm going to check it to make sure that it works. What that means is I'm going to take my equation, which is y equals negative 4/3 x plus 2. I'm going to plug 3 in for x and negative 2 in for y, and see if I get a true statement. If I do, if the left side equals the right side, then my checkpoint is good, which suggests that my line is good. Now this is a 3 over 1. Think of that as a fraction. The 3 on top cancels the 3 on the bottom. So negative 4 times 1 is just negative 4. Negative 2 equals negative 2, and we've checked. So here's my line. I make sure it extends across the whole entire graph. I plot a couple points. I label things, and I'm going to, somewhere at one of the ends of the line, actually write the equation, negative 4/3 x plus 2. I expect your graphs to have all of these things. Labeled points, a shown checkpoint where you're showing the check, arrows, scales, and a labeling of the actual line itself. Okay, there's slope-intercept form, y equals mx plus b. The next form is standard. Standard form is when the x's and the y's are together on the same side of the equation, ax plus by equals c. You may or may not remember that you can find the x-intercept by doing c over a, the y-intercept is c over b, and the slope is a little bit more forgotten with this form, but you find that by doing negative a over b. And the key to standard form is identifying what's a, what's b, and what's c. And note that negatives are terribly important, okay? The negative values are incredibly important. B is negative 2, C is negative 12. So here I'm going to find the x-intercept. To graph this line of the x-intercept, I do C divided by A, which is negative 12, divided by 4, which is negative 3. So the x-intercept is right here at negative 3, 0. Next I'll do the y-intercept. The y-intercept is C divided by B, which is negative 12 divided by negative 2, which is positive 6. So the y-intercept is here at 0, 6. 2 points make a line, and so from there I can actually just graph the line. I can also find the slope. The slope is negative a over b, which is negative 4 over negative 2, which is 2. So I can, from one of these points, like from this point here, do a few more dots, up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. Now I'm going to graph this line. Goes like this. I'm going to pick one point that wasn't one of my intercepts to check. Okay, so here's the point 2, 2. That one seems pretty easy. It's got the same value twice, and that's kind of nice. I'm going to check the point, negative 2, 2. X is negative 2, y is 2. So I'm going to plug negative 2 in for x. Here's my equation, 4x minus 2y equals negative 12. I'm going to plug in negative 2 for x. I'm going to plug in 2 for y. And hopefully I get the same thing. Negative 8 minus 4 does in fact equal negative 12. So that's a check. I should label that this right here is me doing my checkpoint. I am checking the point negative 2, 2. Good. So now that this line works, I'll finish this up. I know this is the line 4x minus 2y equals negative 12, and there's me graphing standard form. Now this is a really quick review of both those two forms, but like I said, this is a review. If you need more practice, maybe come see me or find some more videos that practice the things you need to practice. Let's talk about slopes for a second. Pause the video when I'm done talking and find which of these lines have positive slopes, which have negative slopes, which have a slope of 0, and which are undefined. Okay, do these four first for their slopes. Notice how helpful it is that I labeled things. There's a whole bunch of lines that can get really confusing, but now we know this is the y-axis and this is the x-axis, and that helps. The only two positive slopes are lines B and D. Right here and right here. You're going up as you go to the right. If you have a positive slope, then as you're hiking, you go up as you go to the right. That's a positive slope. Negative slope means you go down as you go to the right, and that's only happening at E. Slope of 0 means you can just walk forward on a flat line. There's no up or down at all. There's the slope of 0. So that is line A. No slope is undefined because you can't actually walk forward at all. You just smack into the wall. In fact, you can't walk forward. All you do is fall down. You fall forever. You don't even die because there's no ground beneath you. You're just falling and falling and falling. A no slope or slope undefined is a vertical line. This is line C. Whereas a slope of 0 is a horizontal line. Don't get those two things confused. If I was to list the x-intercepts from least to greatest, they move along like this. The first one is B. Should pick a lighter pen. The first one is B. The next one is here, and that's E. The next one is here, and that is D. And then we have this one here, which is barely past it, and that's C. Notice that A has no x-intercept. The y-intercepts from least to greatest are going to start here and go up. So my first one is D. My second one is E. The third one is A. And the fourth one is actually way up here because this line continues, so it's B. Sweet. So to recap, when you're graphing lines, plot 2 points and give a checkpoint. Use a straight edge and label axes in the line itself. Show the check with your checkpoint. Show this. Be able to graph from both forms, slope-intercept and standard form. Positive slopes go up as they go to the right, negative slopes go down as they go to the right. And be very precise and clear. A graph should take little time to read or interpret. You should just have a very clear, labeled, obvious graph that I can just glance at and understand what's happening. Good. We're all set. Till next time.